Let's just see if that is working. It is. Right. We are now officially live, and I believe that the people who are watching it live are about 6 minutes behind us. 6 seconds behind us due to the lag. But if they have any questions, you're welcome to email info@livingmaths.com. And of course, we do have some guests that are joining us live in the actual chat as well. So hopefully they'll get to ask questions. But our special guest for today is Dr. Robert Howard, and he is a NASA scientist at the NASA Johnson Space Center. Is that correct?
That is correct.
Okay, so
in Houston, Texas.
I want you to talk me through what it is that you do and what is your title. So what is your involvement with NASA at the moment?
Okay. My title is that I'm a habitability domain lead. That means I'm sort of an expert in the area of spacecraft habitats, understanding how people live and work in space. I also co-lead a group of people called the Center for Design and Space Architecture. That's a team of us. Some of us are engineers, some architects, some industrial designers. We're sort of a concept development team for early spacecraft development. NASA has, as part of its charter, to essentially explore space. So we know about the International Space Station, which is orbiting the Earth today, but that's not the limit of NASA's charter. We want to go essentially everywhere in the universe. In our timeline, we're not going to get very far. Mars is pretty much the horizon for where people think. I tend to think a little bit beyond Mars, but still within the inner solar system. But our group will serve whenever NASA's looking at a different concept or different mission. We answer sorts of questions like, how large does the habitat need to be? What needs to be inside it? How do we arrange different work areas and living areas with respect to each other? We do that a number of different ways. Some of it's analytic, where it's spreadsheets, calculations, concept of operations documents, sort of all of the written type material. We also do design work, and that's CAD modeling, that's sketching, virtual reality. For some vehicles, we'll take it up to the point of physical prototyping. Usually that'll involve our lab in conjunction with other labs across the center or across the agency, where we will build physical models, and we'll work with our usability lab, the human factors engineering lab in our branch, and we'll bring in test crews. Sometimes it's engineers, sometimes it's astronauts. We'll put them inside either our physical mock-ups or our virtual reality models and have them go through a series of exercises to evaluate that particular design, see if it's suitable, see if there are things we should learn from it to tweak or improve future designs, or even down select between competing options.
Wow. So, I mean, that's quite a broad range of tasks that you're involved with. But more importantly, I mean, I want to know, like, how did you get there? So you need to give us a little bit of a background in terms of where it all started for Dr. Robert Howard. Before you became Dr. Robert Howard, you must have started.
Well, there are lots of different ways to end up where I am, so there's no one path. But to tell you my story, I guess we should go back to the age of 3. That was the first time space was an interest to me. Before then, I didn't have I kind of always knew what I wanted to be when I grew up, but that was the first real career I had. I had another one before where I said I wanted to be a house bus driver. Now, everyone in the world is wondering what a house bus driver is, because that career does not exist. But as a 3-year-old, and this is how you knew I was going to be a design engineer, I had come up with this thing called a house bus. It looked like a 2-story mobile home that ran on train tracks. And I'm really not sure why I came up with that, or why I thought there was a career in it. But at the age of 3, that was the thing that fascinated me, and I was going to drive a house bus. I even found drawings when I was like 5 or 6, detailing the house bus. But my sisters used to love to ask me, what am I going to be when I grow up? I'd say a house bus driver. We all knew there was none. They said, how are you going to get one? I said I was going to build it. They said, with what? I said, with wood. And they said, where are you going to get it? I said, from Handy Dan. That was kind of like the Walmart or Lowe's of the day back then. So that was my first career. But somehow space came into the picture. I don't really know what it was, but I started watching Star Trek. I started watching this other show called Space 1999. I don't know if anyone of you have ever heard of that one, but most of you probably know about Star Trek.
I have. Those were the little habitats they used to fly with those little things and land. Was it on the moon?
It was on the moon. It was Moon Base Alpha.
Moon Base
One
Alpha.
of the. It wasn't a terribly realistic show looking back at it now, but it was, for a 3-year-old, it was fabulous. But that got me interested in space. And so when I started going through elementary school, one of the talents I developed, I could go into any library, school library, public library, I could find the space section. I just didn't know the Dewey Decimal System, but somehow I just found my way over to the space books, and I used to read all of them that I could. I'd always just soak myself in everything I could find that was space related. By the time I got into middle school, I was doing my science fair projects on space topics. I always wanted to go to space camp. My parents said they couldn't afford it. But my senior year in high school, I found a space camp essay competition. They said, "You're the director of NASA with limited funds. Will you choose a space station, a moon base, or a Mars expedition, and why?" And I wanted to win. So I looked at the criteria. They said creativity was a criteria. I said, I will never win if I pick any of these 3. So I said, instead, let me come up with this thing that I'm calling the Mobile Space Base. It was a modular spacecraft. You could assemble it in orbit, and it would act as a space station. You could launch propellant tanks up to it, reconfigure it, turn it into an interplanetary spaceship, use it to travel to either the moon or Mars. It also came with a number of landers. You could then land the components and assemble a surface base. So my answer was, don't pick, do all 3. And I won the scholarship, so I got to go to space camp. Now, what was funny to me...
Alabama one. Was that the one in Huntsville, Alabama?
Yes, the one in Alabama. That is there are lots of space camps, but to me, that is the absolute best one in the world. That's just my personal opinion. I got to go there twice on essay contests, so I really loved that camp. But anyway,
I just want to ask you one quick question. So you always loved space. Was there a space influence at home that made you...
I'm sorry, no. I grew up in Greensboro, North Carolina, so there was no NASA center in the whole state. The nearest NASA...
Talk about it. I mean, what switched you on?
It was just part of me. It's the only thing that's been consistent after the house bus. And I'm even going to call the house bus a prototype lunar rover.
Well, that's exactly what it is.
It's not. I'm joking.
So would you say that your passion for STEM was something that was just born out of, the environment, or do you think that there was a little bit of nurturing, maybe your teachers at school that encouraged you? Was there an event that maybe you got excited about?
I really can't remember which came first, me liking space in general or me watching Star Trek. The two were both part of me since the age of 3. And it wasn't teachers at school. It got to the point where they were asking me about space. There was in, I want to say 5th grade, the library at my elementary school asked me to put together a little, wasn't really a display, but it was a little drawing and a write-up about space. But teachers were basically viewing me as the person to talk about space.
That is interesting. Very interesting. So you were already a leader at a young age?
I guess in a way so, yeah. But space was just the passion. So, go ahead.
Yeah, no, go ahead.
So I was trying to figure out how to get to space. When I would read up, this was back in the mid 80s. So at that time, most of the astronauts were military. I was thinking, I've got to go military if I want to go into space. So I was going to go to the Air Force Academy. And I'd applied. My mom and I were having a big back and forth about that because she wanted, several of her brothers were military, and she didn't have anything against the military, but it always had them traveling. So she really missed her brothers, and she didn't want to see her children shipped all over the world. So she really didn't want me to go Air Force, but I was set on the Air Force Academy, and I got accepted. I was about to go to the Air Force Academy. People were calling me. That scholarship was, back at that time, it was equivalent to $125,000. So people were calling me at school. They were calling me the $125,000 man. But my mom was like, she's got to find another way. Somehow or another, she found out that Morehouse College had gotten a NASA scholarship. So she sent them a packet of all the things that I had done. And they called me and said, will you apply to Morehouse so you can take this scholarship? And so I always tell people that I applied to 5 schools and went to the 6th one. At that time, it wasn't on my list. I had the Air Force Academy as my main one, and I was all but on the plane for that one. I had 4 backups. My mom insisted that I have backup schools, that I wasn't dependent on just one. So I was all set to go. Then Morehouse came, and with the NASA scholarship, it included not just full tuition, but also internships and full room and board as well, but also internships at NASA centers. Wow. So I was like, when I saw the NASA internship, I was like, that's better than the Air Force Academy. So at that point, I changed to Morehouse and went there.
But now wait a second.
And
you don't just get in to a scholarship like that if you're not a pretty decent student.
Well, that's true. Now, my parents are both educators. They're retired now, but they were both. My father was a college business professor. My mom has taught at all levels from college down to elementary school. So they constantly were on top of our education. When we were younger, I think this went from kindergarten through maybe middle school. They would check our homework every night. My father checked all of anything that was related to math, so that included the science. My mom checked anything related to English. So every day we had to do our homework when we got home. We couldn't play, we couldn't watch TV till we'd done our homework, and they checked it. So they insisted on education.
That's an important lesson, because now the parents are homeschooling. They're realizing parents.
Yeah, they've got to do it for real now. They also had an expectation of college. For us, the choice was not, are you going to go to college? It was, you get to choose which college you go to. And they got better with each of us. I was the 3rd of 4. So by the time they were raising me, they gave me an additional requirement. They said, you're required to earn an academic scholarship for your education.
Wow.
So they knew they couldn't send 4 people to college. So we were going to have to earn our way through academics. They started teaching an SAT preparation class. In America, the SAT is a aptitude test that you take.
Entrance exams?
And they got better with each of us. My brother's 6 years younger than me, and they ended up having to bring him to class when he was in the 6th grade because they didn't have a babysitter. So he ended up being exposed to SAT preparation from 6th grade through 12th grade. By the time he took it for the final time in 12th grade, he only missed 1 problem on the entire test.
Wow. That's
any lesson there, SAT preparation, don't wait till anyone tells you. Start it right away, whatever age you're at now. If you're able to read, you should be in SAT preparation.
Well, I mean, it's funny to say that, because a lot of we're working with several organizations, and one of them is where I teach online overseas, mainly to schools in America. And another division that they've just launched is to do college preparation, SAT preparation, and career counseling and guidance and that type of thing, because they say that is massive in the US.
It is. It really is. And the advantage of starting early is you get a lot of repetition. In those early years, you won't understand everything. Probably the most you'll benefit from is vocabulary. But over the years, that'll add up, and that knowledge will compound on itself, almost like compound interest. So by the time you get to the ages where people normally say you should start taking it, that repetition will put you at a huge advantage. So don't wait till 10th grade, 11th grade. Start 6th grade, 5th grade, 4th grade, or as early as you can start.
And for those of you watching, this is very important advice, because this is not just being sucked out of the air. This is through life experience. So that's very important.
Absolutely.
Okay,
Absolutely.
So you're getting all these scholarships, you're going to the university, and then what happened?
So I got to Morehouse College, and this is where it would have helped if there had been other organizations that provided engineering exposure to youth. I didn't know anything about engineering when I was going into college. So I was trying to figure out, what major am I going to major in? Only thing I really knew was computers, because I had a home computer and I liked to program. So I started out in computer science. That really wasn't what I wanted, but I didn't know what I wanted. And I knew I was good at computer science, so I went in that major, and it was actually easy A's in computer science because it was teaching programming, and I'd been teaching myself programming since the 8th grade. So again, that's another thing where start kids early. Some of the critical skills I would think would be programming, CAD modeling. If you can do either of those as a child, it will carry huge benefits.
Do you know
if you can get into 3D printing?
The irony is that schools now are adopting 3D printing. They're looking at coding as part of the curriculum.
Good.
And we, as a STEM-based NGO, we go into schools and do the robotics and the coding and working with Lego and looking at 3D printing and I mean, these are critical skills that they're starting at a very young age. Can you imagine how dangerous they're going to be?
That's very important. It's going to change the world. And for the kids who participate in that, it's going to change their lives. It's going to give them opportunities that they just would not be able to earn otherwise.
Sure.
But anyway, I get to Morehouse, and I'm majoring in computer science. It's going really well. It's easy. It's even to the point where some of the professors who are trying to be difficult, I already know what they're going to say. I mean, I already know the subject matter before they explain it. Mm-hmm. So I'm talking to other students in the class who are lost, and I'm like, yeah, I understand that. If I didn't understand it, I wouldn't have understood what he just said, and I would explain it to them. But then I started doing my internships at NASA, and I wasn't happy. They were trying to place me, and I'm the guy who designed the mobile space base to get into space camp, so I want to design spaceships. And they're putting me in the computer services branch because I'm a computer science major, and I'm thinking I could be doing this for Kmart, I could be doing this for Walmart, I could be doing this for General Motors. Correct. I didn't come to NASA to do basic computer programs. And I started talking to people, and they suggested maybe your major's the reason why. I even talked to a couple of astronauts, and they were awesome. It's a little more difficult to get to the astronauts right now, but back then their offices were just no different from anyone else's office, and you could just walk in there. And so I did. I just walked in there and talked to some of them. One of them, who you may have interviewed at some point, is Gregory, Colonel Fred Gregory. He was the first African-American to command a space shuttle. Mm-hmm. And he was one of the three who were in the first group of Black astronauts selected by NASA. And he went so far, I told him my major, told him things I was interested in. And he walked me around the astronaut office and talked to other astronauts and said, hey, do you think computer science is the right major? And they were like, no, you need a hard engineering. You need an engineering. And things have changed since then. Back then, computer science was a lot newer of a field. So it is more valid today. In their day and age, it wasn't really as valid. But for what I wanted, it wasn't the right thing. I want to design spaceships. And a computer scientist could have a role in that, but wouldn't have the role that I wanted. So when I went back to Morehouse, it was the beginning of my junior year, and I said I want to change my major. So I changed. Morehouse has a dual degree program with several other engineering schools. They don't have engineering themselves. But the way it works is you go to Morehouse, complete a 3 to 4 year curriculum, then transfer to the engineering school, complete a 2 to 3 year curriculum, and you graduate with degrees from both schools. So I changed my major from computer science to general science at Morehouse. That was to get me out faster, and aerospace engineering at Georgia Tech. So I did that, made the change. Aerospace engineering was no longer easy. Computer science was easy. Aerospace engineering was hard. And it really took a determination to stay there anyway. It got to the point where I felt like I was not going to be able to graduate. I'd always worked hard, and I believed in working hard, but there was this one class called System Dynamics. And I would study, I would ask questions, I would try to do the work, I would go in and take the test, and the tests are graded 0 to 100 points. I would get a 35, I would get a 15, I would get very low Fs. Mm-hmm. And I was trying as hard as I could try. I would stay up late studying. It was interesting at Georgia Tech, they intentionally make things difficult because they want to see if you've got the mettle to succeed. Mm-hmm. The mentality is almost like we tie a weight around your neck and throw you in the water. If you make it to shore, you're good. Uh-huh. But it was depressing. I felt like no matter what I do, I'm not going to make it. And I had this feeling, this mentality of I'm a ship that's been sunk. And my propellers are turning, but I'm under the water. And I said, I'm just going to keep on going until either I crash and they say you have to leave, or until I break water. So I didn't give up. I did have to take that class again, but I took it again. And this is a college lesson, especially for high school seniors who are about to go to college. Sometimes you have to change the professor. So there are certain professors in college who are known as gateway professors.
Mm-hmm.
I had a different professor at Georgia Tech say he likes to keep his class average at 60%, and he sets the questions on his test to do that. And it's just a mentality. There are different universities with different mentalities. That mentality was present at that time in aerospace engineering at Georgia Tech. It may not be there again currently. It may be different, but that exists in the American system. You'll find it in some places, not in others. If you don't give up, you can make it. I think that's the big test they're trying to see. Are you willing to persevere?
Well, that's a very important lesson for those, even at school. You know, a lot of people find math and science difficult, and it's very important that they realize that you just have to persevere. I mean, this COVID virus thing, I mean, we're going to be sitting at home and there are going to be many challenges. Some people are going to be without salaries, and I mean, it's going to be difficult. But if you just give up, then you're not going to even have a chance of achieving.
Exactly. Mm-hmm. So I didn't give up. I took the class again, but took it from a different professor. It was still a difficult class, and maybe seeing it the first time around helped, but my grades were much, much better. And so I passed that class, moved on, completed my degree, moved on. Now, I knew I wanted a doctorate. My father had a doctorate, and that was something that had always inspired me. But also, when I finished my aerospace degree, it had focused on the vehicle systems. So, and it was more aircraft than spacecraft. I really wanted spacecraft.
Yeah.
But I also wanted to know, how does the human fit with the spacecraft? So I went on to get a master's degree. And, oh, by the way, I had internships during that time. I was in mission control. Enjoyed that immensely. I was doing space shuttle mission control in the guidance and control systems group. So it's space shuttle GNC software. I loved it. Went to grad school, but I wanted to understand, how does a person interact with that vehicle? Because my focus is spaceships that people live in.
Yeah.
So I went to North Carolina A&T State University. I was deciding what school to go to. And so I was applying for fellowships, applying for admission. I had several choices all over the nation, but my mom had some good advice. I'm from Greensboro. That's where A&T is located. She said, you can go to one of those, you can go to another school and get money to pay for your education and have to struggle with where you're going to live and what you're going to drive, or you can come to A&T. You'll stay at home, but you can use your fellowship money to buy a car. So I was like, okay, I'm going to school for free. I can go to school for free with no vehicle, or I can go to school for free and buy a car. So that was no choice. So came to A&T. I majored in industrial engineering with a focus in human factors. And so that taught me a lot about human interaction with all types of systems, whether it's vehicles, whether it's processes, just understanding about how does the human and the machine interact, and how do you design a machine so that the human can operate in it. So that kind of gave me a piece that I was missing from my undergrad. But then I went on for my doctorate. I really wanted the spacecraft. Up to this point, hadn't really learned what it is that's different about space vehicles versus air vehicles or terrestrial vehicles. So for that, I went to the University of Tennessee Space Institute. I picked that because of one of the professors, Dr. Gary Flandreau. Before he became a professor, he worked for the NASA Jet Propulsion Laboratory. And he helped develop the trajectories that were used by the Galileo space probe and other vehicles that explored the outer planets. So studying under him was something I really wanted to do. And that's important in your doctorate level, to go somewhere where there's a professor who's doing something you're interested in. So I went there, got my doctorate. In my dissertation, I focused on what I love the most, spacecraft design. At the time, NASA was not going back to the moon, but I was interested in the moon, so I picked a lunar program. It was a conceptual design of a lunar transfer vehicle, and I based it off of using a spacecraft called the X-38. That was something I had one of my internship tours working on. It was supposed to be a crew return vehicle for the space station. It ended up getting canceled in budget cuts, but it was a really neat idea for a spacecraft that could be permanently docked at the station, and if there was any emergency, they could hop in it, push a button, and 45 minutes later, they'd be on the Earth. Instead, right now, the Soyuz spacecraft that they use, that's their escape vehicle, so they can still get off in an emergency. But the X-38 would have carried more people, so it would have let us get to a bigger crew earlier in the station's development. But that was fun. After that, I came to NASA, worked full-time, started working in the space station group in mission control, where I was doing GNC just like I was with the shuttle. I liked that, but I wasn't as satisfied because I picked up some more skills when I was in grad school. And design was what I'd always wanted to do. It's what I'd been doing since before I knew it was a career.
Mm-hmm.
And right about then was when the Columbia accident happened. And my mind kept going to how could we have designed the shuttle safer so that they would have had a way out of it? What could we do differently for future shuttle missions? But that wasn't Mission Control's job. Mission Control's job is to operate the vehicle that they've been given, which is a good job,
Mm-hmm.
but it wasn't a design job. And an opportunity came up to move to the group that I'm in now and do human factors and habitability design. I switched over, and that was a good thing about NASA. You can change jobs dramatically. So I switched over, came to do that job, and I've loved it. Been doing that ever since.
Wow. So that's quite a journey to get to
Mm-hmm.
where you were. But I think it's important that it needs to be acknowledged, because a lot of people think, oh, look, he's there working for NASA and he's doing all these cool things. But in order to reach a certain point, you have to walk several miles to get there.
Mm-hmm.
So
Exactly.
you want to think that you were just given the position, you had to earn that, and
Mm-hmm.
that was through blood, sweat, and tears. But now I want to talk about some of from what I think is fascinating, and that is the moon versus Mars. To the moon first, and then to Mars, or why on earth are we even thinking the moon when we've done that so many times? Why don't we just go straight to Mars? What's your view on that?
Okay. So first thing, moon versus Mars. That's like ordering a burger and saying meat versus bread. To me, you don't have one without the other. It makes no sense to do one and not do the other. Now, this is just me talking. This is not government policy, the president's policy, the administrator's policy. It's just me.
Yeah. And I was why? Why do you think it's the meat and bread together?
Okay. For me, my passion is extending beyond the Earth. So any reason I would have to want to go to the moon is also a valid reason to go to Mars, and vice versa.
Mm-hmm.
I want to go both places. I want to see humans living and working in both places. There are a lot of the practical things, like the moon is closer, so you can go there faster, you can get more infrastructure on the surface, you can do more testing there. Even if that weren't true, even if the moon and Mars were equally far from each other, I would still want to go to both of them. I think some things that are really key about the moon. One thing about the moon, it's the only place where we could put, or let me back up a bit. If you're really into astronomy,
mm-hmm.
I can go to you and ask you, where is Mars? And you can point to me in the night sky and say, there's Mars. If you had someone tell you, you can come say, there goes the International Space Station. And for that 5 minutes it's passing overhead, you can look at it. You don't have to know anything about space, and you can tell me about the moon. You can tell me where the moon is. No one has a hard time finding the moon in the sky.
Mm-hmm.
So there's something unique there. If we put civilization on the moon and you have people living there, they can look up in the sky and see Earth. People on Earth can look up in the sky and see them. That is the only place in the universe where we can have two human societies living in, or it's the only place in the universe where people on Earth can look up and see another space society. So I think that is really transformational in making us a multi-planet species, to have the two worlds within view of each other. So that's key about the moon to me. Other fun things about the moon, I had a professor tell me, I haven't done the math to see if this is true, but I had a professor tell me that because the moon's gravity is 1/6 of ours, if you had an arena there that was pressurized, you could put on wings on your arms, flap, and fly around. I don't know for certain that that's true, but the very fact of the 1/6 gravity, that multiplier is going to open up so many different ways of human existence that's not possible on Earth. I think there are all sorts of new forms of entertainment, of psychological expression that are going to be possible on the moon that aren't possible elsewhere.
Uh-huh.
So I think the moon's got intrinsic value for human experience. Now, Mars itself has its own value. It's another world. It would be the first opportunity to put humans on another planet and develop second planet capability.
Mm-hmm.
So Mars is fascinating to me for that aspect. So it's not Moon or Mars, and everyone forgets about Venus and Mercury. I want to see us go to Venus and Mercury too. Now for Venus, that would be the atmosphere, the upper atmosphere. At altitude, atmospheric pressure on Venus is equal to Earth. So there are some things you could do. You still need to overcome the atmosphere itself because there's sulfuric acid in the air. So there's a materials challenge there, but that's engineering for the chemists to work on. They can solve that.
Uh-huh.
For Mercury, you have to stay at the poles. The poles are the only area where the temperature is manageable, but there could be interesting things being that close to the sun. So all 4 inner planets are places I want to see humans go.
Okay, so now I mean, I'd love to hog the conversation, but I know it says here that Liam went to space camp in Huntsville, and he wants to know, does NASA have a scholarship now? And is there any advice on getting an internship?
Okay, let me answer that in 2 separate pieces. The NASA Scholars Program that I was under was canceled. It was cut from the budget in the early 2000s, so that program doesn't exist anymore. I'm not sure if there are any that have replaced it, so you'd have to do some digging. There may also be non-NASA programs that include NASA scholarships, or NASA internships. So I've lost touch with what's out there, so you'll have to look. In terms of actual internships and working at NASA, it's a tricky proposition, and I didn't get a chance to go into this when I was talking through my background. I needed a scholarship that was a full ride. I couldn't afford college any other way. But the best way, for my center, the only way to really be sure that you've got a good chance of getting hired is to be in what's called the Pathways program. That used to be called the co-op program for those who knew that name. But it's basically a student work program that NASA has. Most new hires are graduates of the Pathways program. Now, a tricky thing with Pathways is that you can't be on 2 government programs at once. So you can't be on a NASA Pathways student and be on another government scholarship program. That was really challenging. So and it was really disappointing too, because when I had my first internship, the person who was the co-op director at the time said that we're glad that you're here, but because you're an intern and not a co-op, we can't hire you. And that was really demoralizing for a lot of the students who are in my program. Mm-hmm. And they kind of just said, okay, we're just going to take this full scholarship and blow off the internship and just kind of hang out. But I needed the scholarship to pay for my education, but I also wanted to be a NASA employee. So I stuck with it, and it turned out eventually down the road there were arrangements that could be made. In my graduate program, they actually would remove me. I don't know if they're still able to do this, but in grad school, it's a little different from undergrad. They really want you to succeed. They don't do the weed out thing much in grad school. You have to make sure you find a school that's supportive. But if you've got someone who's aligned with your research, aligned with what your interests are, they're going to try to help you succeed. They would literally remove me from their program roles to allow me to co-op at NASA, and then they would re-enroll me at the end of my co-op tour. So I don't know how closely that skirted the rules or if they're still able to do that.
From what I can tell, it does happen frequently, and from a lot of the people that I work with who are involved in NASA, there is a culture of trying to bring in talent and involve them in the right areas, because, as you know, I mean, Elon Musk, he gets that. If you pick talent and you put them in your team, you can build rockets that can do anything. And NASA certainly does see the value in that. So now I know there are a couple other questions. So if you want to, let's go with Joseph. You want to unmute yourself and then just ask your question.
What about other moons, like Io and in other moons surrounding other planets? Do you want humans to go on there?
Absolutely. So Phobos and Deimos for Mars, near-Earth asteroids. I think the inner planets are probably as far as we're going to be able to go for a while, at least until we have a new propulsion system. Getting to the moons of Jupiter would take a long time, so I don't know that we can get there even with nuclear thermal thrust. But I would love for us to go there. I would love to be in a submarine in the oceans of Europa or something. So I think it's a matter of new propulsion systems will get us beyond the asteroid belt, but till then, Ceres might be as far as we can go.
Okay.
I have a quick question. So with the asteroids, I was watching this thing a while ago in Cape Town, and it said that asteroids contain a low level of oil. So what if we harnessed oil out of the asteroids and turn it into fuel for the rockets.
I did not know that. I know that some of the gas giants have hydrocarbon chemicals. I didn't know that there were any asteroids with any hydrocarbons. But whether it's hydrocarbons or water, water is another important chemical for rocket propulsion. The most powerful chemical rocket you can generate, it uses liquid oxygen and liquid hydrogen as its propellant. And of course, that comes from water. So whether it's hydrocarbons, whether it's hydrogen, oxygen, whether it's methane, any sort of propellant that if we can learn to harvest it and refine it in space, it'll help us to go further. We think we can do that. There's water on the moon. There is water on Mars. There's methane on Mars. Some asteroids we think have water. So there are resources out there. It's a matter of developing the capability to leverage and use them. And that's something I hope we do.
All right. And Manjula from Sri Lanka, you wanted to ask something? You just have to unmute yourself. There we go.
So share some information about Titan. So it is, I heard some news on Titan that it's possible in Titan as well. It is some methane or something like that in Mars atmosphere.
So Titan, is that a probability that we could land there and just deal with the methane?
Robotic probes, yes. Now, getting people to Titan is, because of its distance, is something that's currently beyond us. I would love for that to change in our lifetime, and maybe it will. Right now, we don't have anything on the books or even hypothetically on the books that would get people to as far as Titan.
Thank you.
But I know some people, after spending time in isolation, who I'd like to send to Titan, but that's a whole book all on its own.
Actually, those of you who become engineers, take that as a challenge. See if you can develop a rocket system that'll get us to Titan.
And when you find out how to do it, just let me know, because I've got a few volunteers that I'd like to volunteer on their behalf. So, I mean, but Mars is obviously not a simple planet to visit. What are the complexities involved in not only just getting there, but to actually live on the planet?
Everywhere in space is complicated, so don't think any destination is easy. Not even low Earth orbit, even that's difficult. Mm-hmm. But Mars is incredibly difficult. The distance is the first thing that's huge. Depending on your propulsion system, the most advanced hypothetical systems that don't even exist, the shortest anyone has ever gotten theoretically is 90 days. But that's the system that right now requires magic. Now, for a real system, you're talking 6 months to a year. That's one way just to get there. Once you actually get there, depending on the trajectory you chose, you may be able to return right away. And those are what's typically called opposition class trajectories, where you take a long trip to get there. You can only stay there for a short time, and you have a long trip to get back. The other class is conjunction. It's still a long trip there, but not as long. But when you get there, you're going to be there for a long time, hundreds of days. Those have ranged 300 days, 500 days. So during that time, you can't come back early. So if there is an injury, if there is a mechanical failure, you've got to deal with it there at Mars. So that's another huge complexity. We've never had to deal with that in human spaceflight. For the space shuttle or space station, with the station, we have logistics vehicles that come up and bring new supplies. For shuttle and for station, we have deorbit flight rules. So if something goes wrong, back in the shuttle days, if something went wrong with the shuttle, beyond a certain set of failures, they would just pack up and come home. For station, beyond a certain set of failures, they jump in the Soyuz and come home. Can't do that for Mars, so that's another difficult thing. Then there's the radiation environment. Doctors really don't know what the radiation is doing to the body. We know it's probably not good, but the experts don't agree on how bad it is or how serious, or are we talking issues that would affect the crew during the mission or issues that would affect them after the mission. So there's a lot of uncertainty and speculation about radiation. That's something we've got to deal with. Food shelf life is another problem. For those long missions, the food spoils. So we're learning how to deal with that. There's the psychology of a small crew that's away from Earth, can't get back. There are issues with the microgravity during the transit. and it's a complete unknown for the low gravity on the surface. It's 3/8 of Earth's gravity, but we don't know if that's just fine or if that'll cause medical problems. So lots and lots of things that we're still learning, we don't know, and it's just difficult.
Okay. Liam, did you want to ask something? I'm not sure if Liam does want to ask something. Maybe he does.
Or maybe he's muted.
He might unmute himself and then he'll ask us. If not, Caleb, do you want to ask anything?
Hi, sorry.
There we go. All right, Liam, what would you like to ask?
Can you tell us anything about the space launch system on the moon to get to Mars?
Okay, I heard a couple different things in there. The Space Launch System is a rocket, and we're planning on using that rocket for both missions to the moon and Mars. It's not my area, so I don't work it directly, but it's derived from the space shuttle. It uses the space shuttle main engines, but where the shuttle had 3 main engines, the SLS has 4 main engines. They're mounted to the bottom of the tank instead of on the shuttle, since obviously there's no shuttle in the SLS. It has larger solid rocket boosters, so it's basically a more powerful version of the shuttle. And of course, there's no orbiter, so it doesn't bring the orbiter up into space. Instead, all of that payload is your payload for deep space. They're designing it at Marshall Space Flight Center in Huntsville, Alabama. So it's a different center, different set of people working it. They build it at the Michoud, or they build the core stage, which is just like the propellant tanks, at the Michoud Assembly Facility in New Orleans. Northrop Grumman builds the solid rocket boosters. I don't know offhand where their production center is. I don't remember. But it gets barged to Kennedy Space Center, where the whole rocket is assembled together for launch.
And it's a big one.
It's a huge one. When it launches, I plan to go to Kennedy to watch that launch. I always wanted to watch a shuttle launch. I went down twice, but they canceled both times, so I never got to see it. But I'm definitely going to travel for the first SLS launch.
Have you seen any of Elon Musk's launch?
Yes, I saw one of the Falcon Heavies. I saw the launch and landing.
Did you see that landing on its own?
You broke up, but I think I understood your question. Yes, I saw the 2 side stages land. That was a beautiful sight to see.
Mind blown. I mean, just to get over the fact that someone could actually get 2 vertical boosters to land like that was just, that blows my mind.
Yeah, it was very exciting.
Wow. And of course, people are talking about Mars and saying 2030. What's your gut feel on that one? Do you think we're going to get there in the next, 10 years?
Okay. This will be my opinion, not any NASA opinion.
I'm asking you.
So there are different dates that are talked around. It's really not about those dates. NASA's job is to, a lot of people sometimes forget NASA's a agency of the government. So NASA's job is to implement the space-related priorities of the nation. Mm-hmm. So what we're going to do, where we go, when we go, it's really a function of what the government wants. And so when the government's of divided opinion, then that delays when we go. When the government changes its mind, that changes where we go. So it's more a question of, when does the government want us to be on Mars? To the extent that that's determined, that'll drive when we get there, whether it's the 2030s. I don't think we could do the 2020s, but if the government said the survival of the United States depends on landing on Mars in the 2020s, we would find a way to do it. We might not like it, but we would find a way to do it. But it'll be what's important. They've got to balance so many competing priorities, though. So when we get to go, we don't really know. We just know that every day we're trying to move closer and closer towards that date.
Do you think we'll be around to see it?
I intend to be around to see it.
That's what I want.
I really want to see that attitude take hold. This is me personally. I cringe whenever we say, you children are the fill-in-the-blank generation, whether it's the Mars generation, the Moon generation, the whomever, whatever. I want us to be, whatever the goal is, I want the current generation to be the generation.
Yeah. Well, it's doable. I mean, Elon Musk is pushing the envelope on a daily basis, and it's so unpredictable. And yes, he does mention some grandiose projects of settling many thousands of people on Mars, and whether that's doable or not is another story. But I mean, so far he keeps surprising everyone with what he can do. There's a good chance that he might get his own team to land on Mars before NASA.
That's entirely possible. It's also entirely possible that the NASA landing will be on SpaceX contracted boosters. I mean, NASA always contracts with industry. It's part of NASA's charter. So it's not a SpaceX versus NASA. One of the things that I do hope is that we do have private spaceflight where there are missions. I want the NASA missions to continue, but I want to see missions into space that are in addition to NASA missions. So whether it's a SpaceX mission to Mars, a whomever mission to the moon, a whomever orbital hotel, I want to see all of those happening.
Well, that's always a good thing. And I'm asking this obviously to you. Did you ever secretly want to be an astronaut?
It was no secret. I definitely wanted to be an astronaut. I still want to walk on the moon.
So you have a few little things around the house, just, for fancy dress parties. It's not like you've always wanted to be an astronaut. You just can't help these sorts of things.
I don't have a space helmet. I do have a zero-gravity flight suit because I did get to do a Zero-Gravity Corporation flight a few years ago.
How
it was wonderful. Too short, but wonderful. Now, they have a business model. It was short on purpose.
Okay.
The NASA, I never had a scientific reason to fly on the NASA microgravity spacecraft. They would typically fly like 45 parabolas, and they had the nickname the Vomit Comet.
Yes.
Because that motion, it makes a lot of people motion sick. The Zero Gravity Corporation is trying to make money doing this, so having people throw up probably is not good for the business model. They studied it and determined that 15 parabolas plus motion sickness medicine would keep most people from getting sick. So that's how they scope their flights. And I would have loved to do longer. I wouldn't have minded. I would have tried not to throw up. But I would have traded 30 more parabolas for throwing up.
And what about commercial space travel? Because as you know, Blue Origin is really moving forward, and Virgin Galactic, they're moving forward. There's a good chance in the next 5 years you'll be able to buy a ticket and just float around for 45 minutes or so.
Very true. Now, Virgin Galactic is asking for like $250,000, and their price may go up. I could pay that if I sold my house and lived on the streets. It's not worth being homeless, so I'm not selling my house, which means I can't afford a Virgin Galactic ticket. But
it used to cost
$20 million
to get a ticket. It used to cost $20 million.
That's an orbital flight. That's Virgin Galactic is suborbital.
Correct.
The orbital guys are going to charge more. I can't afford it, but what I'm waiting for is for some entrepreneur to create the first space lottery, and I will absolutely buy a $10 ticket every week.
Now that is a smart move. I like that. But I mean, if they did get a little bit of competition going, then those prices could drop. And I mean, if you could, for $20,000, fly on a suborbital flight, would you do it?
No, it's my income. I mean, I could take a loan and pay off $20,000, but I'm not going to do that.
But so it's not the driving force.
Well, I mean, to me, that's for most middle income people, that's just not a responsible use of money. Bring it down a little bit further, make it $2,000. I'm buying that ticket.
Okay, so you are negotiable. All right, I'm just trying to work out where your point of negotiation was. I mean, I was just thinking, if I sell the kids, would I be able to get the ticket? Joking, I'll give the kids back in a hurry. Are there any other questions that you guys want to ask? I did notice that there was a question about qualifications. We did kind of touch on that, Manjula, but we'll come back to that if there aren't any other questions. Do any of you guys want to ask any questions? Lorraine, you've been quiet as well. Lorraine out there in Boston, you want to ask any questions? Don't be shy. Well, while Lorraine is, I see a hand up. We got Joseph. What do you want to ask?
Could the space launch system get to Mercury if we want to send a crew there?
I haven't done the orbital mechanics calculation, so I don't know for certain, but it could probably either send something to Mercury, or more likely, it would assemble a spacecraft probably in Earth orbit or cislunar space, and that spacecraft would then depart Earth and travel to Mercury. That's the approach we're using for Mars. It's not going to launch crew directly to Mars. It's going to launch components up to cislunar space. It's going to build an interplanetary spaceship that'll go to Mars. Mercury would probably be done the same way, assuming we go to Mercury.
Okay, thank you.
That's a great question, but of course, I'm going to ask you two tough questions. One, I want you to talk about the naysayers who say that obviously the moon landing was faked, and that'll take a while. But the second one is a lot of people are saying, why are we wasting money on a trip to Mars? Why Mars when we should be focusing on our own planet?
Okay. The first one I'll deal with quickly. There are people who think we never went to space. For me, working at NASA, seeing the people, there's still a few people here who actually worked the Apollo program.
Mm-hmm.
You can see it in their souls. This is something they did. It's like telling you that something that was an important part of your life just didn't happen. And you see them, you know that it was part of their life. You see the after effects of it. Mm-hmm. Then there's all of the hoax theories. It's really someone who got a glimpse of the program, didn't understand what they were looking at, and concluded it wasn't real. Mm-hmm. One of the ones that was funny to me, because I work in mission control, is they talk about the flag. The flag that's planted on the moon looks like it's flapping in the breeze, and some people say, oh, that means they weren't there because the flag won't fly in vacuum. Well, of course not. And think about the 60s. It was a nationalist time in the world's history, and the United States wanted to say that it was the best. It's better than the Soviet Union. So mm-hmm. They wanted a flag that people would see. So they put wires in the fabric so it would stand up so that it would look good in a camera shot. And we have a copy of that flag in Mission Control, so you can walk over and look at it and see it. So when I hear those conspiracy theorists, it's like, okay, you guys don't even know what you were looking at. Mm-hmm. So all of the hoax stuff, it's silly. On the surface, it was someone who couldn't understand what they saw, and fake was the best explanation, but the truth was a lot simpler. Now, in terms of why... Go ahead.
We have imagery, not just from the guys that took photos on the moon, but we've got satellites that go past the moon and around the moon and take photos, and they've got evidence of landing sites and moon landers and that type of thing.
Yeah, I meant to mention that. Yeah, the probes that are up there now, satellites, they're taking pictures, and they're seeing all sorts of vehicles that we've launched to the moon, vehicles that are in space. I expect at some point that's actually going to be an industry, tracking all of the old space things that are lying around the solar system.
Well, that's what Naeem spoke about yesterday, that they're busy writing a blockchain system to manage all space debris, because if people keep launching satellites and new things into the environment, into the atmosphere, and you already have several thousand items around, if you don't manage it, it's going to become a problem, because if these two things collide, or if something hits a space station, I mean, you can imagine the implications.
Right, it does need to be tracked. Yeah. Now, in terms of why do we spend money and effort in space, I'll use a metaphor. If you've played any sports, any Little League football, basketball, your coach has had you run laps, and you don't ever run laps in a game. So you might say, why am I wasting time running laps? Well, running the laps builds your body. It makes you a better athlete, so you're more capable of performing in the game. Mm-hmm. One of the advantages of spaceflight, because it really challenges every domain of human knowledge, it takes our entire ecosystem on Earth, the very carefully designed system of balance that allows humans to live, it packages that into a small vehicle and sends it outside the Earth. That action, that task of overcoming the challenge of doing that, makes us stronger, makes us more capable as a human species. And that allows us to apply that knowledge to all sorts of things. There's even advanced knowledge that's being used to fight coronavirus today. So coronavirus a century ago would have been way more devastating than it is today. Every time we push ourselves in technology, whether it's the space program, whether it's other industries, we're constantly making ourselves more capable as a human species, and that enables us to overcome the challenges that we're facing. So space is just, it's not the only one, but it's one of the key ones that develops us. It's also a good uniter. During the 80s, it was the middle of the Cold War, and everyone thought that the United States and Soviet Union were going to destroy the world in nuclear weapons. That was kind of when the Cold War ended. But one of the things that emerged at the end of the Cold War was the United States and the Soviet Union coming together in space. That even happened in the 70s with the Apollo-Soyuz test project. Space is something that's so inspiring that even groups on Earth that don't like each other, they both like space, and it becomes a common bond. So it makes us stronger, it makes us closer.
That is a great answer. Great answer. Any more questions? Just click on the little hand if you want to ask a question. We'll give you a last chance to squeeze in a question. Don't be shy, because I still got lots of questions. So I'm going to take that slot if you're not going to take it. I'm watching all the windows. Anyone got a window? Maybe they're a little bit too shy. And of course, some of them would have switched off their webcams because, we did say to some parents that if they don't want their kids to be seen on the internet, at least they can hear them and they can still be a part of the interview and also have people watching the live stream as well. So for those who are watching the live stream, thank you for joining us wherever you are in the world. And for those of you that have joined us over here live for the interview, we appreciate that you were here and asked some questions. All right, we've got about 3 minutes left. My final question to you is, what sort of advice would you give young people if they were keen to get involved in the space industry? Because obviously it's not just a case of getting into a rocket and flying there and wearing the uniform. The space industry and even new space is a whole massive commercial aspect to it as well. So if they wanted to get involved in space, what would you suggest they do from even elementary school level?
So first thing, have a dream and be excited about it. Allow yourself to be excited about space. That should go without saying, but it's really important for you to enjoy your job. So find the things about space that you like. Now, while you're doing that, you also need a good foundation. So your schooling is of utmost importance. All the math, all the science, all the reading, all the English, all of it matters. None of it, don't think of any of it as unrelated or extra. Learn everything you can, as much as you can, and be as good at it as you can. Everything that you learn is going to help you. It's going to come together in some way. The math is obvious, the science is obvious, but there will be other things that you're going to pick out of history, out of economics that you would have thought are completely unrelated, but one day it's going to matter. Test preparation, what I was talking about earlier. Understand what the tests are that you need to get into the college you want. Start preparing for those immediately. There should be no waiting. Do things outside of schooling. So your extracurricular activities, your clubs, organizations, get involved in those. Make sure it's something that's fun for you. Get heavily involved, get leadership positions. Those are going to develop you in other dimensions, and that's important as well. Focus on making sure that you're a good person. So your faith, your personal philosophies, whatever they are, be true to those. Learn from role models. Any role model who's willing to spend time with you, learn from them, gain from their learning, benefit from their presence in your life. All of it comes together to make you a better person and prepare you for your future. Learn everything you can about space. The more you know, the better. That's never an entrance requirement, but I always notice that people who came and didn't expect to be in space, they always have a little bit of catch up where they're trying to understand the terminology, understand what different programs are, whereas for other people, it's just rolling off their tongues like second nature. Won't say that you have to be a sci-fi junkie, but sci-fi jokes are very common at NASA. So if you happen to love space, then all the better for you. One of my groups loves to joke that the answer to everything is 42. So if you know where that comes from, you're a step ahead.
Galaxy. See, maybe I'm one of those that belong to the group. What is interesting is that, I mean, you've managed to literally sum up the salient features in terms of what it is that a young person needs to get in there. And from my side, I just want to encourage math and science, all the STEM subjects. Don't be afraid to pursue that, because if you think about problem solving and critical thinking, those are incredible skills to have when you are finished school and when you're going to university and going to college. So it's very important that you pursue those particular disciplines, and don't forget the arts are important too. I do like arts, but I do think that the maths and science is pretty important to go with it. So on that note, we want to thank Dr. Howard for an incredibly informative interview, for giving us background information. If you guys have any additional questions, send them through to me and I'll forward them on to Dr. Howard. And I'm sure he won't mind answering those questions. But one last thing, what is NASA doing about lockdown? Because the world is now literally stuck. Are we going to leave our astronauts up in space while we all sit here and ride out the virus? Are they worried about sending the virus up to space because then we're going to have an alien contamination? What's happening? And what's the general feeling in NASA at the moment?
It's pretty much the same as everywhere. I think the astronauts in space might like to stay in space, maybe. So we're actually taking very, very careful efforts to protect them, and that's in general, not just with COVID, but we're always very careful about not sending viruses or bacteria to space. We don't want crew to get sick up there, so everything going up there is very carefully controlled. So they're the safest people on Earth right now. Now, for the rest of us, we're managing. I mean, we would love to be in our labs. There's a project that my group is working on where we're outfitting a chamber for a 12-day test that's going to sort of test exploration atmospheres and also test habitat design at the same time. All of our manufacturing for that's on hold. We're still doing the design work, but we can't come on site to do the build out, and we're kind of disappointed about that. But at the same time, we understand that we need to be safe, so we're fine with that. And around the agency, it's the same thing. There are certain people who are essential. They've got to go in to keep the station running, to keep the center safe. So they go in, but the rest of us work from home, and we stay busy. I mean, I've got enough work that I do a full work day from home every day. There are other parts of my job I would like to do and I look forward to doing, but there's enough that I stay busy working on spaceflight from my home.
Awesome, awesome. Well, thank you so much. What I would like to do is I'm going to stop the live broadcast here. So let me go to end live stream.